DevOps part of it, like how to do CI/CD kind of implementations with machine learning. So when you're implementing your machine learning projects, generally all the things, how you deploy to Azure Machine Learning and how you test or train the model is normally performed as manual actions or via command lines sometimes. But it is like the time to people to get started with how to do this stuff in a proper way, enabling proper testing and proper deployment strategies, so that the team who are developing the models or team who are actually preparing the data for the models doesn't have to worry about how to get it deployed into the next environment or like next target environment. So that's the aspect that I'm going to discuss a little bit in today's session. So if we go to the agenda, so what I'm going to use is use some sample machine learning code, because I don't want to go into a much complex implementation, but rather I would pick a very small sample machine learning code which is doing some analysis, and then I will implement a Azure pipeline to train the model using that ML code. So then publish and deploy that output in the build itself as a pickle file. So if you know how the model can be downloaded, it can be downloaded as a pickle file. So I'll show you that how it works. And then I will move on to the next part of it and take the published or deployable package output and deploy it into another workspace in Azure, like simply another machine learning workspace. So that's what we are going to experience, and then we can see how the integration test or test can be run. So if I move on to my next slide, like just to explain you the build steps in brief, but I will be actually explaining you using the actual build. One thing that we need to keep in mind is like these train model stuff runs somewhat longer. So we might not be able to completely execute the build pipelines that I have developed in this particular time period, but what we can do is I have shared these projects as public projects in Azure DevOps, so you can go ahead and experiment with these, and I have created a wiki as well, so I'll share all this information with you towards the end of the session, so that you can go and experiment in the same way and understand how it all works. So in the build steps, what we are going to do is simply get started with the validation of the data to train the model, and then publish these data to the quality reports to the test results of the build. And then we are going to create a resource group and machine learning workspace and a compute cluster using Azure CLI machine learning commands inside the Azure DevOps build. And then we upload the data files that we have in our repository. Then using that data files, we are going to train the model in the development environment or development machine learning workspace. And once we do that, we will have a model which is trained. Then we are going to register that trained model in the dev environment, and then download that registered model from the dev environment as a pickle file. So then we will be putting that in a build output along with other necessary files that are required to do the deployment. Now these files, development of these Python codes are part of ops and in combination with the data science people, so that I mean it's mandatory to take the data science people's input, and then some guy who is having experience with DevOps or like kind of implementing CI/CD pipelines need to understand this, and he should have some ops idea and need to write the required scripts. So let's have a look at them in detail so that you will understand what I'm talking about here in summary. And once we have this build output, what we are going to do is we are going to use that build artifact and then we are going to deploy this into a target, another target machine learning workspace, which is getting created as a new one. So we are going to use the output and generate the model again and register the model again in the target environment, and then we are going to run some integration testing just to make sure the deployed model is working fine. So that's the whole part of this workflow that I'm going to present to you. So let me begin with moving on to Azure DevOps. So in here, what I have used is actually the sample code from Sasha Dittman. He has a MLOps lab, which is having detailed information on how to do MLOps on Azure. And he has some video series as well, but they have some issues you need to get fixed. So in this code also, you need some small changes to be made to make it work with Azure DevOps fully as of now. But this is the theory behind it. So what we are going to do is train the model, package the model, and then validate the model. And what I am going to do is additionally download the model and make it published as a build output, and then take that output and deploy it into a new target. So that's the flow that we are going to do. So this code I have cloned into my Azure DevOps. So you can see the same code base is existing here. So this code base has several parts. So let me take you through the important parts that are mattering to the deployments and build pipelines. So let's have a look at them in a quick. So one thing is like how to keep the data files. So these data will be, general CSV files. So this is some bad data, some good data, and like general data. So this is a very famous model that is diabetes training model. So that's what we are gonna have a look at today. So I'm not going to talk about much of data science part of it, but rather I would be looking at how to implement the pipeline of it. So this is the data files that we are going to use. And when it comes to deployment, now these YAML script do the magical part of most of it. So we have Azure Container Instance deployment and as well as AKS deployment configuration YAML created here. But what I'm going to use is this ACI deployment, because like in my machine learning model, I have implemented as a Azure Container Instance. So that's what we are going to try to deploy and get it up and running with the pipeline deployments into the target. So let me move on. So you can see there are tests also written, and then there are scripts to do the trainings. So the train diabetes this can be actually, these commands actually can run on manual way, and you can actually execute them in your command line using Azure CLI and Azure Machine Learning extension to the CLI. So you just need to set up those things and then you can execute them. But like getting it via a build pipeline is again using the Azure CLI commands plus some additional activities like properly putting the things in place. So let me move on to the build pipeline and show you how you can get these executed. But all this code and everything is like available in GitHub as well as available in my repo. So I will share this link. So this is a public project available in Azure DevOps, so you can also use it. As well as I have written a wiki about this, which I will show you in a moment, because this is kind of bit complex steps that we are going to look at. It would definitely help if you can follow it up after the session even. So that's why I created this wiki for you guys, so you can you can see there are two wikis, how to create the ML build and how to create the ML release. So all the pipeline creation instruction and what you need to do in each step is available here. So you can go ahead and have a look at that. Once I'll share the link in the chat of the presentation, so that you can later have a look at that and then start practicing these things. So let's move on to our build pipeline and have a look at how it is implemented. So let's discuss about that. So let me move on to this one. So okay, so what we are going to do here is like we are going to use the code from the repo and just getting things ready. So one thing that is required is the Python extension. So we need to use Python version 3.6 because this code relies on that version. But if you are writing your code in much newer version, if you have them, that's okay. So you can use other versions. So I'm not 100% sure what is the latest Python version or anything, but I think this is sufficient for this code repo. So you can try it out with that. So when you have some sort of a basic solution, you can go ahead and implement it for your actual projects as well. So then we need to set up some additional Python requirements for this particular project. Now that is again defined in the file. So let me show you those information. So in this setup, we have all the requirements of additional requirements of what we need to have additionally. So we are going to use this scikit-learn model, so which is a famous model to train this model. So you can see that is what used as the requirements for the pipeline, or even to get the model trained. So for that, actually, now since we are using hosted Azure agents here to do the model training and to get the model deployed and registered in the dev environment in Azure Machine Learning Workspace, we need to make sure this agent is capable of executing these Python scripts. So in order to do that, we need to set up these initial requirement setup. Then what we are going to do is we are going to execute a test script written, that is a data test Python script, which is actually going to test our modules or whatever the data models that we have defined. So again, these things are depending totally on your project, how it is. So depending on the code base that I have used, I actually created all these commands so that it can go and check the data quality in the pipeline itself. And once we execute these tests, you can see the result output is made as a JUnit, and we are going to create a JUnit test results file. So we can actually utilize that into publishing into the pipeline. So that's a one advantage, so that you can even see the data quality tests, like the data can be pre-validated, and those tested results can be shown in the pipeline itself, so that it will help you with the visibility. Otherwise, like, these details are kind of hidden, so you only know when you run it. You have to go through XML or something output, and then I mean it's really not that readable. So if you implement this as a CI build, so whenever you commit your machine learning model improvements or like data improvements, that result will be available in the build, so that it will benefit you a lot. So the next step that we are going to do is like actually install the Azure CLI extension. So you can see that I'm using Azure connection. That is, you can create Azure subscription connection into your Azure DevOps using service principal. So what you can do is you can create a service principal using a command line if you want, or like you can go and manually create app registration and get the service principal implemented, and then you have to configure that service principal as a service connection in Azure DevOps, so that you can create the bridge between Azure DevOps and Azure. So once you have that connection, you can select the Azure subscription like this. So I will not go into in detail about this service connection because that is a much available knowledge. So I will skip that part, but this is how the Azure service connection is obtained here. And then we are defining this as a shell script, and I'm going to execute the first command, the getting the extension added, because generally in our hosted machines or Microsoft hosted agents, we don't have the we might not have the Azure CLI machine learning works extension installed. So in that case, we need to make sure that is already there. So what we are going to do is make sure that is by let me zoom in a little bit if you can't see this. So this actually executes and add the extension for the machine learning, and then this actually goes and create the entire thing from the beginning. So what happens is even the resource group is created automatically. So if the resource group is existing and the machine learning workspace is existing, it will not be a problem. This script can be re-executed again because we are using this special flag called exist OK. So that means like if you are running it in the second time, if the machine learning workspace is available in the resource group, it won't give you an error. So it will continue executing without any issues. Like it will not create the thing, but it will reuse the existing machine learning workspace. So these commands actually facilitate those things. So this is a very useful command line set of extensions, so which actually facilitates Azure DevOps to achieve the pipelines with that. So what you can see here is it's actually creating the workspace with the workspace name and the resource group name and your desired location. So these things are just variables. If you're a little bit familiar with Azure DevOps, you know how to define variables from here. So those variables can be utilized in there. So that's the set of variables that we have defined. So you can see the resource group is defined as this, and even you can define all the other information. Like what is your paths and etc. etc. So we will go to the tasks and continue the discussion. So let me try to make it more okay. And once we have the machine learning workspace, the next thing that we require is a compute cluster kind of thing. So we need to get our model trained. So for that one, actually here what I am using is a ML compute cluster kind of thing. So we just have a set of nodes which can be executed, which can execute the data processing and get our model trained. So for that purpose, actually this ML compute cluster is getting created. So you can see this particular command does a lot of parameterization. So you can just create a ML compute target with as a Azure machine learning compute target, and inside the same resource group and using the same workspace, machine learning workspace. And I'm just defining a couple of nodes, like minimum nodes is 1 and maximum node is I'm setting as 3 in the variables. So I'm just creating a 3-node compute cluster where we can execute our training of the model. So that's what is done in this one. And then I can set the scale down also here, so that whenever it's not in use, the scale down of the cluster will be automatically happening, and when the load is there, the cluster will automatically expand. So these things are important if you are concerning about securing or like securing the cost, like cost factor. If you are worrying about the cost factor, and if you are making sure you are keeping it down and low as much as possible, you need to make sure you are actually implementing the proper scaling as well. Okay, so the next step is like just put our data, the CSV files that I have shown you, inside the machine learning workspace default storage account. So that's what is done here. So you can see like it's actually a command called Azure Machine Learning Data Store Upload. Maybe you guys are using, like if you're familiar with these machine learning data model training stuff, you might have already used these commands in your computers manually, and then you might have uploaded data, or like you might have used the portal itself to do the stuff. But I believe like when you're using these command lines, you can achieve this inside the pipeline. So what this does is, this is actually uploading the data files. To upload the data files, we need to know what is the default data store of the workspace. To get that, actually this is a second command executed inside this command. So if I highlight up to this part, it's actually a command within a command. So this, what this does is, actually it goes and retrieves the default data store name. So that default data store name is utilized in this one to upload the available data folder. So this is actually referring to the repo data folder, and the target path will be the target path of the data that is actually we are creating as diabetes slash data. So that is the path that is going to get created in this Azure blob container. Actually, it's getting uploaded as a blob container data. So your files will be uploaded to Azure blob. Then actually we need some intermediate folders inside the agent to when we are executing the this pipeline, we need to keep when we are training the model, we need to keep some additional metadata about running, and then we need to download the model. So in order to do those steps, we need to create two directories. That's what is done here. So it's a very simple bash script. Then the next step is actually training your model. Again, this is a command line which is allowing you to do that. So you can specify how your machine learning script can be utilized here. So you can see that I have parameterized all the things, but like so the workspace name is very clear, and the experiment name is the experiment name that we have defined in our code. So that experiment can be used, and we are going to utilize the compute cluster that we have created, and then we are going to use the conda dependencies file that is actually available in the repo, and then we are going to run these things, and then output metadata will be put in the metadata folder that we have created. So that's how this is getting executed. So let me move on. And once the training of the model, like this might take actually around 20-30 minutes in this particular model. So once it is done, actually you can register that model in the workspace, and then once you register the model, you can actually download that. So using that metadata files, you can actually register the model in your workspace. So once the model is registered, you can download model as a model pickle file. So that's the next step that we are going to do. And once that is available, it's general stuff that is done here. That is actually we are copying out the metadata folder, and the let me expand this a little bit. Okay, we are copying out the model model's details and the deployment files and required, because we are going to utilize them in our deployments to get it deployed into another workspace. So for example, if I go in here back to my machine learning, so you can see I have a demo dev environment here, and you can see I have a demo dev int environment here. So this is the one that I have utilized and executed the build with, and this is the one that I have deployed as the dev integration environment. And as the next step, what we are going to do is we are going to deploy it into a QA environment. So you can see it doesn't have to be the same machine learning workspace, but in different machine learning workspaces, you can deploy using the build output. So that's what I want to show you, that it doesn't have to be a single machine learning workspace. So you can use multiple machine learning workspace, because in other application deployment strategies, like any other like web application or like function applications or any other application deployment strategies, we generally keep multiple environments, like our development environment, then our target environments as QA or testing environments, and then staging environments and the production environments. So when we are keeping these multiple environments, setting up all these things manually and putting stuff there in manual is going to be a headache. So that is what we are going to avoid here by implementing pipelines. Like, this is very kind of basic level at the moment with machine learning things, but it is getting on improved. So since the machine learning extensions and CLI is available, we can actually go ahead and do this stuff in a much more better way. So you can even see like the model is available here once I deploy it. So you can see this model is available here, and you can see the deployments of the model is available as a Azure Container Instance. So you can even see the SCO URL here, which actually can be used to consume it from a web service or from a from other whatever the services. So this is actually deployed using a deployment pipeline. So let me take you to the deployment pipeline as well, and then explain it in a little while. So this one actually then publishes our output. So let me go to an executed build and show you how it is got executed, because if we try to execute this right now, it will take a lot of time to get executed. So I will try to skip that part, and I'll execute a deployment process and show you how it's getting executed. So let me go to a executed build already. So you can see I have executed a couple of builds. So this one actually the training part took about 12 minutes, but you can see there is a then download model and all those stuff. So altogether this build has taken 18 minutes. So that is a thing that you need to concern. Like normally in a general CI pipelines, it takes about 2-3 minutes or something like that. But when it comes to these kind of machine learning builds, it might take a couple of more minutes. So in that case, actually what you can do is you don't have to execute for each commit. Rather, you can either schedule it for 2 hours kind of intervals, or like kind of batch process it, so that you can get your code that is committed is validated as well, but you are not exhausting the resources available in Azure DevOps. So what is happening here is, like, you can see the see when we are training the model, actually it is executing. So if you go through these logs, you will I mean, if you are familiar with how it is done, you can see that we are using a Docker container to train the model, and then all these logs. I mean, I don't have time to explain all these logs, but these logs will give you all the information how it is actually got executed with the training of the model. So Azure DevOps will provide you full visibility into your trained model and how it really works. So you can go ahead and explore and find out if there is any issues. Those will be also available in the log, so you can actually diagnose if there is any problems. So once we do such a publish, what we will get is a build output like this. So let me show you such a build output. So this is a build output. So what we have generated out of the build using the Azure Machine Learning Workspace would be something like this. So this is actually a model that is downloaded as a model pickle file. So this is the file that can be used to deploy it into another target. But in order to deploy this one, we need some additional support files that are the deployment support files. So it will allow, I mean, we have two different deployment strategies here, but I'm going to use only the first one for today. You can even deploy this same model pickle file into a AKS cluster mode. So instead of using Azure Container Instance, you can use Azure Kubernetes services as well. So this code sample is really great in that sense. That's why I use that one. So you can learn how to implement pipelines very easily with this one because it's actually having a lot of details. So then this setting up of the initial requirement for Python is required for us even in the deployment steps, because we are going to run integration test. We need to have these Python requirements added to our deployment machine, that is deployment agent, which is doing the deployment. And then there is a test integration testing, which needs to actually verify the deployed model and use the score URL and test it out. So let me just show that test integration test for you to get an idea. So when you go into tests in the integrations, so what is there for the integration test is, it's actually using a sample set of data, and it's going to call the score URL and then utilize that sample data and validate the execution of the score URL. So that will make sure that you can consume this machine learning model after you deploy it. So your training happens in the build, and once you deploy it, it can be utilized. But in the deployment, we don't do any make changes into your model. We just deploy it. So this can be executed multiple times, so that you can train your model multiple times in the build, and then you can deploy it to your targets. So that's the whole purpose of doing that. So let me take you to the release pipeline and show you how it really works. So in the release pipeline, what I have implemented here is the steps that I have described in the slides as well. So you can see I have created two environments to demonstrate to you how it works. So if I go into edit mode of this pipeline, so this is what I have implemented. So I'm using the build output of the my CI build, and then I'm actually running a development integration environment, and then I'm running a QA environment deployment. So I'm actually going to create two different resource groups and two different machine learning workspace in this particular example, because I just want to show you it can be deployed into multiple workspaces. So for example, if you go here, as of now, you can see the dev int environment is created, but the QA is not executed. So I have even removed the QA resource group from altogether from here. So there's no such resource group. I only have the dev integration environment and my development environment where I used to train the model. So only I have these two machine learning workspaces as of now. But once I execute the next step, approve it to QA, it will create the QA environment as well. So we can go ahead and do that, because it will take some time. I'll let it approve and let it process, so that while we are discussing the rest of the pipeline, we can go ahead and see how it is getting executed. So when you have a look at of this development integration environment, you can see there are test results available, and we are only executing one test over this one. So you can see the test results here. So test of the ML service is so you can see it is getting executed and it is getting passed, so that those information are available here. And when you, I missed to actually show you the build pipeline results as well. So if you go to build pipeline, even you can see in here, whatever the data validation tests also executed fine. So this kind of a setup will give you the visibility where you want, I mean, whenever you make commits, or like you batch your commits and run a schedule, so you can see whether your code is stable and whether your data that you're using is valid according to the criteria you are setting up. So you can set up your own criteria and validation scripts and get them executed with the build, and make sure, like, it's like general concept of using your code unit tested. So for the data, like machine learning, the most important part is data. So what we are trying to do here is validating the data to make sure we are training the model in the proper way. So the model's capability of giving the desired results would rely mostly on how you train it. So your training data is the most important thing. So that is what we are validating in the build here. So it's similar to we are executing unit tests inside our normal applications. So in the release pipelines, what we are trying to achieve is actually after the deployment, we are just going to validate whether we have a valid set of model deployed, and we are verifying whether we can consume that service. So that is what the difference between executing tests in build and executing tests in the deployments. So when it comes to the deployment pipeline, let me take you through the steps that we are doing. So while that is getting executed, I actually wanted to do this fully step by step, but I checked the timeline, and then with the 40 minutes, I don't think I would be able to even get started and do halfway even. So that's why I pre-prepared everything and just showing you how it works, and I'm sharing all this code base for you to have hands-on experience and get it working for yourself. So you can see, like, again, I'm using this Python version, and then what I'm doing is I don't need to set up the Python requirements until I come into the step of running integration tests, because that is the only part that is going to be run inside the agent as a Python script, but other things will be just again machine learning commands. So what we are right now doing in the deployment is simply something like this. Let me take it into a more smaller part. Okay, so you can see, like, the first thing that we are going to do is make sure that we have the machine learning extensions for Azure CLI is installed, and then we are going to create a new workspace. Again, it's not a complex thing. Similar to what we have done in the build, we are going to implement or create another machine learning workspace in a new resource group. So depending on the variable setup, it will actually create a new machine learning workspace. So once we do that, now we don't have any upload of data or doing any training of the models here. We are just deploying the already trained model here. So we already have a trained model as a model pickle file. So that is what we are going to register in the new workspace that is created. So here, instead of training or like trying to register a model after training, we are just using a model pickle file that we are having in our build output. So it's simply the model pickle file that we are going to register in the target environment using the metadata that is generated in the build. Then once we register the model, we are going to deploy the model so that it will create the necessary Azure container instances, so that you get this core URL which you can actually consume and use it in your web applications or whatever the application that you need. So that is the core URL will help you to consume the model that you have deployed. So once that is done, we are going to use this installation of the Python requirements just to make sure that we are capable of running this particular script, which is getting executed with the integration tests. So this step is actually again running the integration tests, and it will execute the Python script and get the score URL tested with the data that we have seen in our repo. So once that is done, we will again publish the test results. So that's the few steps that is getting executed in this particular release step. So this is the same set of steps. Like, actually what you can do is you can make it a task group, and you can make this more valid or professional implementation of the pipeline. So you can make it a task group and reuse in other environments, but I have just copied over the or cloned over the thing. Ideal would be to have the task group created, because it will be the same steps for each environment. So you can just highlight this stuff and then create a task group from here even, so that it will start to utilize the task group. So once you do that, actually you have multiple environments, and you can actually create any number of environments to deploy your pipeline, deploy your model using the pipeline. Now you can see, as in the QA environment as well, we are getting our model registered, that is done, and the deployment of the model is already started execution. I don't know whether I will have enough time to get this fully executed and completed, but let's just have a look at in machine learning area of my subscription, whether we have the QA environment getting set up. So you can see it's already having the workspace and everything getting created. So if you go and check the model, you can see model is available here. And I'm not sure whether the deployment is yet available, but we can just have a look. Yeah, I think deployment is also started, so that's why this information is available here. So you can see if you go here, like, still there's no scoring URL because the deployment is in progress. So once the deployment is fully completed, the scoring URL also will be available here, so that you can actually utilize it to consume your model in your applications. So that's basically covers what I wanted to cover. So all these details are made available to you in this particular wiki. Let me share that wiki link in the chat itself, so that you guys can also utilize this thing. So if there is any questions, I can answer, or like I can pass it on.
No, actually, there is two questions on chat box.
Hello.
There are two questions in chat box.
Okay, let me have a look. Okay, is there a simple way to create MLOps like Jenkins or Travis CI style? Okay, I think it's not that complex. It looks complex, but it's not that complex. What we are simply doing is, like, it depends on how much you want to do. Like, if you want to just deploy it after your like, for example, if you want to do all the development and then just download your pickle file and add it to the repo, right? So you don't need to have all the CI steps of like training the model and all those things. So it depends on what you want to achieve, right? So what I have shown here is how you can achieve the full requirement. Like, you just do your development focus only, and you are going to have all the training and all the model, all the workspace creation and everything is fully automated. So this is kind of like full automation kind of need catering, but you don't have to do all these things. Like, for example, I have created the resource group and I have created the machine learning workspace, and every other resource needs inside the build itself or inside the deployment pipeline itself. But it's okay even if you want to create these stuff using Azure portal manually. You create the machine learning workspace and everything, and then you just do your development and you train your model manually, register your model manually, and download your model. That is also possible. I mean, that's not a okay, just MLOps. Okay, about the simplicity, that is the thing that I can say. Like, it depends on what you want to achieve. Like, here, what I wanted to achieve was the full capability. The developers only need to concern about local development of the scripts, and even getting these scripts tested is handed over to the build. So that's what I wanted to show you can be achieved, but you don't have to go into the complex implementation at the very beginning. That what I can say. Does MLOps support trigger for retain based on accuracy level drops like Auto AI? Accuracy level in the sense, like, I'm not 100% sure what is the question that you're asking about accuracy level. But if you're worrying about the data accuracy level, what we can do is, like, we can make, if a test fails, we can stop the build. So if a test or anything fails, we can like, it's actually even though it's called MLOps, it's actually Azure DevOps supporting machine learning operations. So the implementation is on actually machine learning rather than the implementation is on Azure DevOps rather than machine learning side of it. Machine learning side is like actually having the scripts. So it depends on like how you want to check the accuracy. Like, for example, in the build pipeline, we have checked the data accuracy. So if you want to do some additional integration test writing to validate your model behaving accuracy, yes, you can write it, and then you can execute them. And if there is an issue after the model is trained, and then when you can actually, after training the model, after deploying the model in the dev workspace itself, you can execute certain integration testing onto that model and see if it works as expected. If it is not working as expected, you can actually fail the build if you want. So it all depends on what you want to achieve and how you want to achieve. So Azure DevOps is so much flexible. You can, if you know the command lines and if you know how to implement things, like it's simple. Okay. Okay, so monitoring part is actually, I have not explained here in this because of the short timeline, because I originally planned this for a much larger time scale. So monitoring is actually from the Azure machine learning side, not from the pipeline side. So it is actually happening in the machine learning workspace side. Okay, so if there is any other questions, I can take on, or otherwise I can pass it on to the next speaker. So I don't have that